As a Team 19 from AT University, we had a great opportunity to visit a lab where we had the chance to use LEGO Mindstorm constructors. This lab session was specifically designed to apply the capabilities of the LEGO Mindstorm EV3 robotics platform in order to design and implement a system that could roll complex figures. This particular exercise placed high emphasis on increasing our learning of important concepts such as robotics programming, the mechanical design, and problem-solving techniques that are useful in finding new ways of seamlessly integrated hardware and software to create drawings. The hands-on experience enriched our knowledge and at the same time provide a very good opportunity to bridge the gap between theoretical learning and its practical application in a real-world scenario. We began our work with the assembly of the LEGO Mindstorm EV3 robot. First of all, we focused on constructing a very firm and functional design that could hold a pen or a marker on top. It needed to be stable to keep the drawing tool in contact with the surface and avoid excessive shaking of it. We chose a small-wheeled robot that could draw smoothly because we tested different design and because of its accurate movement.
Programming the robot was a great experience for us. Our team used the EV3 software to create a series of instructions that would guide the motors through specific patterns. First, we focused on simple movement like drawing straight lines and circles. This helps us understand how the motor rotation would translate into robot's movement. Programming the robot was an exciting experience. In the EV3 programming software, we have drafted a set of instructions with which the motors move through specific patterns. First came the simple motions, such as drawing straight lines and circles, understanding how rotations were converted into movement of a robot. Next, code improvements were made by testing different motor speed and rotation of wheels to make sure the movements are accurate. We also had to consider factors such as friction, contrast of the wheels with the ground that may introduce error in the drawing. This process of understanding and adjusting for these external variables became an important part of our experience. We set up the robot with two motors for controlling the wheels and third motor to raise the pen. This setup allowed us to program the robot to draw a series of lines, each with a clear start and end point. For instance, drawing a square meant programming the robot to move forward a certain distance and then rotating 90 degrees continuously until the square is complete. It sounded like such an easy task, but as we worked through the details, it turned out more complex than initially thought. We realized quite quickly that the robot to draw a perfect square, much accuracy and timing were crucial. We also found that minor mistakes from one side of square would gradually add up noticeably imperfections in the final result. We faced a lot of challenges to create a good drawing. Each failure in that case brought us important lessons that really contributed to our success.
One of our first failures was a problem that occurred during the actual programming of the device. Our first tries at drawing a simple square only produced irregular shapes because lines overshot or fell short of their intended lengths by a few units. The mistake was traced back to an erroneous calculation concerning the relationship existing between motor rotations and the distance that the wheels would cover. We had underestimated the various effects that wheel slippage and surface friction would have on our calculations and measurements. We did test to fix the problem and to see how far the robot moved with each motor rotation, and then we changed our code based on what we found. This helped us make the robot's movement more accurate. It wasn't easy, but it helped us understand how to make the robot work better. Another challenge was the lifting mechanism of the pen. First, the motor in charge of the pen wasn't felt synchronized with the motors of the wheel. This resulted in the pen lifting or going down at unwanted times. Hence, unwanted marks on the drawing surface or gaps in the intended design. But we had some delays and conditional statements to the code so that the pen motor operated only when necessary. After making some changes, the pen stayed the same. The next step in our process was making curved shape motions, which included tasks such as drawing circles and arcs. This was achieved through the highly precise control of the motors, making sure that one motor would move at a different speed compared to the other. This amount of control was important because it would enable the robotic arm to make circular movements with great precision. However, it was found that a poorly estimated value concerning the speed and time associated with motor rotation led to results where the circles drawn were.
Further, in the experiment of the complex pattern spiral and star shapes, we face other coding challenges. For instance, to draw a spiral, this robot will mostly draw over where it had already drawn, or it will not make the same size gap between every run. This was actually because of its incorrect logic of loops in the program. We analyzed the algorithm and modified the increment values controlling the radius of the spiral, adding some conditional checks based on the boundaries of the surface where the robot is drawing. The whole process was done by increasing the robot's performance through critical thinking. We closely watched the behavior of the robot after every test and observed how it would behave against its design. We would take such observations and trace the error either in the code or in the mechanical settings. For example, the robot was going sideways while drawing straight lines. We figured out that one wheel was moving a bit faster than the other wheels. We fixed the problem by changing the motor speed in the code. This experience in the lab really showed us the importance of persistence, paying attention to the small details, and learning from our mistakes. Each challenge we faced made us to think more creatively, improving our understanding of robotics and our problem-solving skills. Overall, this lab session was incredibly valuable, not just for improving our technical abilities, but also for teaching us the importance of teamwork and collaboration when doing complex problems.